Today we have something very different for you. This here is a 1960 Super Dominante radio from the GDR, which puts it in a similar time frame as the MD421-2 microphone we looked at in last video.
I picked up this radio for very cheap on eBay from a guy who hadn't used it in years. However, it was not working.
Which means it's up to me to get it up and running again. The very first thing I checked once I had the device in hand was the fuse. Probing it with a multimeter shows no continuity, which means the fuse is probably blown. Visually inspecting it, however, I was able to make out it was simply the contacts being corroded, and with a bit of filing and cleaning up, it was back up and running. After quickly disassembling it fully, for which you just have to undo 4 screws on the bottom and unsolder the speakers, making sure to label the cables so they go back in the right place later on, the whole electronics assembly can be lifted out of the case. Now, before turning it on, I'm gonna clean it up to make sure nothing's gonna short out. Since this was standing in a shop with the previous owner, it was obviously caked in tons of dust and debris. With some paper towels, Q-tips and alcohol, as well as generous use of the vacuum cleaner, we can see the circuit assembly regain some of its beauty. In the center of the assembly, you can see these plates of metal. These are what are called an adjustable capacitor. When the adjustment knob is turned, the plates engage and disengage. The larger the area that overlaps, the bigger the capacitance. To understand what this does, we first need to understand some of the basics of how the radio works. Very simplified, you can say that the antenna usually receives all signals at once. To now select the frequency we want to have, we need what is called a tuned circuit. This consists of a capacitor and an inductor. These charge and discharge each other, resulting in a sine wave of a controllable frequency. When the sine wave that is produced by the LC circuit, that is this oscillator, matches that of a given signal received at the antenna, only the audio signal remains, giving a clear sound. As capacitance influences frequency, the adjustment of the metal blades adjusts the frequency, which is turned into sound. I am specifically calling this a circuit assembly, as one interesting thing about this device is that it is from a time before circuit boards became more common. It doesn't actually use a PCB for most of its circuitry. Instead, all the components are directly soldered together in a pretty impressive mess of wires. There is a couple of modifications which I will be doing to this device. First of all, let's get this ancient, decrepit power cable out of here. It has no protective earth and it has been cut with a knife to fit into the newer sockets. As this does not abide by the CEE 7/4 specification, we will be replacing it with the proper plug and adding proper grounding. The other major modification is adding an audio in and output. For that I will be hijacking the TA input, that being a phono input, and soldering a 3.5mm socket to it, so a phone or computer can be connected and the device can be used as a regular speaker. I took out all the tubes, making sure not to leave any gunk from my fingers on them, and cleaned them down with a dry paper towel. After putting them back in their respective sockets, the radio is almost ready to be turned on again. For that, I'll have to slide it back in the case and solder the speakers back on. I'll also screw the little tone controller back in. Now, for the moment of truth. And nothing happens. Since this is a tube-based system, it takes some time to start up. The tubes need to heat up. But why is this? A very simple vacuum tube is the so-called triad. A glowing cathode puts out electrons due to the Edison-Richardson effect. These steadily flow to the anode, meaning the tube allows for the flow of electricity. Within this flow of electrons, however, there is a metal grid. When a negative voltage is applied here, the flow of electrons from the cathode to the anode is interrupted as its polarity rejects the electrons. When different amounts are applied, the throughput can be regulated. Of course, in actuality, the physics and electronics behind this are a bit more complicated, as this is a gross oversimplification of their function, and there are also more tubes with more complex arrangements for different tasks. Now, once the tubes have heated up and the electrons are flowing, the radio starts doing its job. Interestingly enough, even after 60 years, it works just fine. All that had to be done was to recover the fuse. A couple concessions have to be made though. As Leonard mentioned over on TikTok, yes, that's real, the paper capacitors commonly used in these degrade over time, which leads to an increase in the noise in the system. I sadly can't be bothered to replace all of them due to cost and complexity. Still, even the modifications function, although on the output our noise problem is especially noticeable. Now, this being fixed is still sorta out in the open, as it means the large capacitor needs to be replaced as it is meant to filter low frequency noise.
With all of that done, this radio now finds a spot in my house, hooked right up to a record player.